Hey folks, welcome to WebRTC Part 2. In the last part we went over the basics of WebRTC, what it is, what its history is, and today we'll go into more detail on what's involved in forming a connection and streaming media between peers. The process of discovery and exchange of connection information is commonly called signaling. This is usually done over a signaling server, as we discussed, but it doesn't need to be. So I'll go over a peer discovery process. That's what happens first. So first, you see Alice sends a signal to the signaling server saying, I need peers. And the signaler sends a message to the different users saying, Alice needs peers. And then each of them responds with their name, or it may be like a session ID from the signaling server. So each of them introduces themselves, and then those messages gets passed from the signaling server back to Alice. Now, when the peers have been discovered, what info needs to be exchanged? Well, you need to exchange session descriptions and ICE candidates. What is a session description? Well, a blob of text in session description format, or SDP. You can see what that looks like right over here. For every connection, there is a local description, a description of us, and a remote description, a description of the peer. This description includes information about the media being transmitted, like the audio, video, text being transmitted, and information about how to connect to the peer, such as the IP address and protocol. Usually UDP, because it's faster, but sometimes TCP. Now, what are ICE candidates? ICE stands for Interactive Connectivity Establishment, and ICE candidates include information about how our remote peers may connect to us. WebRTC starts generating these after we let it know what media we want to transmit. We let it know this information through the local description, like I described in the previous slides. ICE candidates are generated and thereby transmitted to a remote peer from best to worst, which I'll return to in a second. So what did I mean before when I said that ICE candidates are transmitted from better to worse? Well, some of the connections are UDP and some of them are TCP. And UDP connections are favored over TCP connections because they're faster, and UDP has better browser support. Real direct peer-to-peer connections are favored, but sometimes it's not possible. A typical reason for this is that the rules of the NAT or firewall don't allow for the direct connection. In this case, traffic may be routed through a centralized server, which is called a stun server. We'll go more into what that is later. How are ICE candidates generated? Well, some are generated from the local network settings. In fact, in the previous presentation, I showed off a demo, and both of those users were simply connecting over a local connection. These candidates will suffice for peers within our local networks, these local connection candidates. Other candidates are generated from a stun server, and others are generated through a turn server. I'll go into what both of these server types are. Now, a stun server is essentially what'smyip.com. It lets WebRTC know our public IP. The candidates we generate from our public network information will work as long as direct connections between the peers are permitted by the NAT rules of their network and firewall. Otherwise, we have to use a turn server. Now, this is a relay server, and WebRTC relays data through these servers, so it streams the media, like the video or the audio, through this turn server. And obviously, we don't really want to use this, because then you have to pay for that server. We don't want to. That traffic can be expensive, especially in the case of streaming video and audio. Now, when you initialize a WebRTC connection object, you have to configure your stun and turn servers. You can see that a Google stun server is being used for this connection object. So we're just passing a WebRTC configuration with the ICE servers into the connection object. And you don't have to worry about the syntax really right now. So let's take a look at this handshake process once a peer has been discovered. Alice creates a connection object, so you can see a peer connection object being formed there. She then creates something called an offer. Oh, sorry, first she adds media to that connection. So I've just created this sort of placeholder function. This isn't part of the WebRTC API, but I'm just adding media to this connection object. She then creates something from that connection called an offer, which is just a session description, including all the media we want to transmit. She then sets her own local description to this offer, and she transmits that offer to the remote peer through some means. So in this case, it's through a signaling server. Bob also creates a connection object, and then he receives the offer. He creates what's called an answer from this connection object, which is also another session description. So you can see it. You can see Bob receiving the offer and setting its remote description to that offer. And you can see it creating an answer. He then sets its local description. He then sets his local description to the answer that it just created. So both the offer for Alice and the answer for Bob are their respective local descriptions. And then Bob responds with that answer, and Alice sets the remote description to that answer. So now both users have a local description and a remote session description containing the media to transmit. They now both need connection information. When you set the local description, WebRTC will start looking for ways to transmit that data. So you can see that we're starting to generate ICE candidates from that stun server. So Alice asked the stun server, what connection info? Stun starts saying that back, which allows WebRTC to start generating the ICE candidates. So the connection object queries the stun server for the client's public connection info, and every time it comes up with a new candidate, it will trigger the on ICE candidate event. So you can see that happening here. We then have an ICE candidate that we can transmit. When a peer receives a candidate, it calls add ICE candidate to add the candidate to the remote description. And you can see that both of these peers are doing that individually. So they're both broadcasting the candidates to each other. Now we're going to start talking about the type of media that we can add. So how do we actually add media? I'll start with the simplest kind of media, a data channel. It's used to transmit text. It's bidirectional, meaning you don't need to create a data channel on both sides of the connection. One client can create a data channel and the other can simply receive it and start transmitting over it. Here are some code snippets. First, I'll explain that on connection needed event. That's triggered whenever WebRTC detects that something about the connection has changed, such that we need to carry out another handshake process. So when we create a data channel on the next line, that event will be triggered. That channel.onOpen event will trigger when the handshake process is complete and both peers are ready to transmit text over the channel. All the recipient needs to do is wait for the onDataChannel event, which will also trigger when the handshake process is complete. So now both peers have a data channel to transmit over. Now, what about media tracks? And these can be either video or audio. And browsers have standard methods for creating these tracks from your camera or microphone. You can also create tracks from your screen for screen sharing. So for transmitting media tracks, we see again that we're waiting for the on negotiation needed event so that we know when to start the handshake process. And we're calling get user media on the initiator which allows us to create tracks from our camera and microphone. Each of the tracks we add will trigger an on-negotiation needed event, which we kick the handshake process off from. So you can see we're requesting a video and audio track, which will ask the browser to request the video and audio from the camera and microphone. And then we'll get streams from each of these. So we'll get the different tracks, which is the video and audio, and we're adding that track onto the connection object. Now on the recipients, we just need to define an on-track event to receive that track on. And that's it. Thanks for listening. Today we covered peer discovery, resources created in exchange for WebRTC connections, the different types of connections, and different types of media to transmit. And next time we'll cover some tools for developing WebRTC applications.